How do you bring a stream back into balance? How do you restore its biological health?
By using natural stream design, we're actually assisting the stream to heal itself when it's sick and not feeling well, restoring some of the natural biological processes such as increasing the number of different kinds of fish that you see in the stream, the number of different kinds of bugs. A sick stream won't have a ton of them, but a healthy stream will.
The more you can mimic nature, the more successful you'll be.
The concept we're applying here is very simply applying natural materials, understanding natural processes, letting nature do its part to protect streams, and managing the energy of the river in a way that works with nature instead of trying to armor the banks and resist nature.
Stream restoration is a process. First, define the objectives for the stream. Is it flood control? Stream bank stability? Improving access to the stream? Improving habitat? You need to understand what you hope to accomplish. It is often possible to achieve multiple objectives with your restoration project. Next, assess the stream. Take a close look at what's going on at that particular site. Is there downcutting or widening? Is the stream bank vegetation healthy and plentiful? Has something changed in the watershed upstream? Or is something constricting the flow downstream? Once you've determined your objective and assessed the stream, you have to decide what is your best course of action. In some cases, removing local stressors such as cattle grazing, stormwater pipes, or culverts, and replacing mowed turf grasses with native, deep-rooted plants may sufficiently improve the quality of the stream channel. However, if you decide that removing local stressors and revegetation is not enough, then you must work with qualified professionals and appropriate regulators, such as the U.S. Army Corps of Engineers, to design and later construct the restored stream channel. No matter which choice you make, you still need to monitor the stream and maintain it in a form that meets your objectives. Natural stream restoration includes 3 parts: reshaping the channel and floodplain, building in-stream structures, and protecting the banks. To begin restoring a stream, first you have to reshape it, moving dirt and rocks to establish a more natural stream channel and floodplain. Reshaping can start with grading banks, creating benches and more gentle slopes. This will reconnect the stream to its floodplain and help slow the water during rain events. The redesign of the stream may mean adding meanders to a straight stream or creating riffles and pools. For some streams, regrading is not enough. Veins are structures built into the channel to control the flow and redirect the water. This configuration of rocks or other materials helps lessen the slope of the stream and moves water away from the banks. The first type of vein we'll look at is called a cross vein.
So we can utilize our vein technology to keep water in the middle of the channel in areas where both banks are vulnerable, whether we have infrastructure or other things on the sides of the bank that we don't want to have erosion at. The cross vein uses our large rocks that are large enough to not be washed away by the energy of our high flows, and we create sort of a V structure that's at a 20 to 30 degree angle from the banks, and they are tied into the banks perpendicular here underneath the ground. You can see these footer boulders that are utilized to keep the bottom structure of our cross vein stable. We have our 2 to 5 degree elevation change here where the water's higher, it moves up and moves over back towards the middle. And then as we move to the upstream end of our cross vein, we have what's called the invert. This is the lowest elevation of our cross vein. It moves into a pool. This is an area that's deeper. There's really great habitat and you get a lot of turbulence, a lot of energy dissipation, especially during your high flows. This one is a double step cross vein, so as we move into our second step, it allows us once again to have that turbulence, that energy dissipation, that great habitat in the second pool, and then from that second pool it'll move up and out into a riffle. another in-stream structure that's similar to our cross vein is our J-hook, that once again has two different functions. It's going to serve as grade control to lower our slope, and it's also going to help us to deflect water from a vulnerable bank. Our J-hook is utilized to move water away from only one bank as opposed to the cross vein that moves water away from two banks. So what we want to do once again is we're going to have our slight slope here on our vulnerable bank side, and this right here is a log J-hook. It could be also constructed of rocks. It's going to be tied in up there at the downstream end of the J-hook and then tied in back into the stream bank. So as the water moves up this vulnerable side, it goes up the slope, up the log, and then it's moved back into the center of the stream where it creates this pool. This pool is once again great habitat for lots of little critters, macroinvertebrates, that type of thing. We're installing this with rocks so that we have little areas in between here that the fish and critters can still get upstream during base flow. This is especially important in some other parts of the country where you have critters that go upstream for spawning and that type of thing. And then on the side away from the critical bank, we have our lower part of the J that's made of rocks here, and it's actually tied way back into the bank all the way to the trees, so that during high flow, when there's a lot of energy on the bed and on this point bar, it's not going to get washed away. In larger rivers such as this, a J-hook may not be practical or even beneficial because of the large amount of energy that is involved with this amount of water. If we installed a J-hook in this area, we would have the hook part of the J-hook out in the middle of the river where the highest energy is, and the size of boulders required for that type of installation would be impractical and very, very expensive. So instead of that, we utilize something called a barb like we have here. And what the barb does is use the same type of technology as the J-hook to move the water slightly upslope and dump it back away from the vulnerable bank into the middle of the stream, thereby protecting that bank from the high shear stress that would be involved with the higher flows. So a different type of in-stream structure is known as towwood. And towwood is really great for stabilizing the outer edge of meander where you have that vulnerable area where the stream bottom joins the bank. So what we're doing on this is utilizing logs and sticks and different brush from around this restoration site that we buried 6 to 8 feet within the bank, and it provides all these little crevices for the little critters and fish and things like that to live. It also provides structure and things that disrupt the flow at the bottom of the stream in the deep part of the stream where the most energy is. Over time, these sticks are going to degrade, but we also utilize live plants to create this towwood, so they are going to sprout and create a tree line along the bottom of our stream bank that will stabilize it over the long term.
After reshaping the stream channel, there will be a period of time when extra stream bank protection is needed. Think about bank protection in 3 steps. Temporary measures, such as matting, that hold the freshly restored bank in place. Then, some quick, short-term plantings, and finally, the vegetation that's going to be there over the long term.
One of the first things we want to do on a new stream bank stabilization is to protect the bank from erosion. Here we do that with straw. The straw is going to reduce the impact of the raindrops as it hits the surface, and also as the soil gets wet, that straw will kind of incorporate into the soil and hold it in place. Down here within the channel where the water will be flowing, this coir matting, which is made of coconut fiber, helps us to reduce the amount of stress that hits the bank and holds that soil in place underneath the matting. The matting will also give us some structure for vegetation to grow through as the site matures.
If you have done a stream bank stabilization project and you have essentially bare soil banks, the first thing you need to do is put a quick growing grass on those banks to protect it from any waterfall, any rain events that come through. Then you need to begin to think about what plants you want to put into those areas to further stabilize them, to really get the root systems going. Plants that are adapted to aquatic systems typically have extensive root systems for that very fact.
That vegetation over time puts in roots that act as rebar and hold soil in place. It helps bind that soil to resist erosion.
You want a mix of vegetation along the bank: grasses, shrubs, and trees.
Things like Bermuda and fescue, which are great for pasture, are not good for stream banks because they have little short root systems. So what we like to see planted right along the bank are things like big and little blue stem, Indian grasses. Blue stem can have a root structure 8 feet tall. So it's really going down and holding all of that in place.
And those roots will help lock that soil and gravel in place so that during future floods, the roots are helping hold the soil, and the plants that are growing above ground help slow the water down, taking away some of the energy that would be causing erosion, leaving most of the flow energy out in the main channel.
There are plants that thrive exceptionally well with their feet wet. So we look to put things like willows and other wetland type plants right up at the toe of the stream so that they can sprout and really vigorously grow to start holding the soil in place. We're talking about trees that prefer being in close proximity to water, that during times of flood when the waters come up, instead of washing out around the root balls, the plants themselves will actually bend with the floodwaters, and then when the floodwaters recede, they'll pop back up.
Trees also provide a number of other benefits for a stream, including things you might not think about. For example, trees cool down the water. Why is that important?
Trees themselves will shade the stream, lowering the water temperature. Many fish species are dependent upon a certain range of temperatures before they can reproduce. And so it's important that they have those conditions so that you can have a growing population. They also allow for the water itself to hold more oxygen, which once again, if you're a fish or a bug, or as scientists will call them, macroinvertebrates living inside the stream, that's important too. You need something to breathe.
Leaves also, as they fall into a stream, serve as the very base of the food web so that we get that carbon input that we need for a healthy ecosystem to support the aquatic insects and a healthy fisheries.
There are certain aquatic insects called shredders that begin to cut up those leaves and chew on them and eat them, and then there are another 2 or 3 suites of different insects that will continue to break those leaves down.
Native plants can give you a head start on revegetating the banks.
And another key in selecting those plants is to simply look around and see what already grows there in areas up and down that stream.
Those native plants we know are supposed to be here because they're all around us. They will get established and grow quickly, plus they serve as that critical wildlife habitat and important habitat, even leaf quality for streams, for the insects in the streams and decomposition rates.
Some non-native plants can be invasive and outcompete the beneficial plants that are vital for a healthy riparian ecosystem.
What we want to fight against strongly are the invasive exotics that move in quickly when we have disturbed areas. So managing for native species and actively trying to remove and slow down the spread of invasive exotics is a critical element of these projects.
All this work can be done to restore a stream, but it will take the continuing growth of plant life to make it a success.
Plants above ground and below ground help serve important processes for stream restoration.
Restoring stream stability and function requires working with qualified professionals in a multi-step process of assessment, design, proper construction, and long-term monitoring and maintenance. This design may include grading to reconnect the floodplain, in-stream structures for stabilization and to decrease the slope of the stream bottom, and lots of vegetation. To achieve success, this type of restoration requires vigilance to ensure plant establishment, especially during the first few years after construction. Additionally, these methods need to be integrated with watershed-based plans and stormwater management on the landscape. Major changes to the watershed can impact your stream restoration. By working together, we can ensure that the natural beauty and function of our streams can be enjoyed for generations to come.